All right. Hi, my name is Andy Hong. I'm an assistant professor in the Department of City and Metropolitan Planning. And I'm really excited to introduce our students and their semester-long work from the Big Data and Transportation class that I taught this semester. And in this class, we partner with the Utah Department of Transportation and work with Wasatch Front Regional Council and City of Salt Lake. And special thanks to you, Stephanie and Bert, if Bert is here. All right, so, for this class, we were tasked with this million-dollar question. So the question was, can we actually use big data to inform planning for bicycle and pedestrian travel? And in particular, we were interested in learning how we can use Strava data. And some of you may or may not know what Strava is, but it's a smartphone app-based activity tracking app, which is used by millions around the world. And quite recently, they made their data available for local governments and municipalities to use. But there are many problems with this data. So our students took this grand challenge of making Strava data useful for planning for bicycle and pedestrian travel. So without further ado, I would like to turn the podium over to Eric to start their presentation. Eric?
Thanks, Andy, and thank you everybody for attending. We're really happy that you're interested in the usefulness of this big data for active transportation modeling. So Andy already kind of took us away and introduced us. We're all students in city and metropolitan planning. We have a PhD student, undergraduate student, and some master's students here with us. So today we're going to spend about 40 minutes on our presentation, and we're going to try and save 20 minutes at the end for questions. So if you do have any questions, write them down, type a note, and keep them for the end of the presentation. Kendall, if you want to advance to the next slide. I want to introduce Strava Metro. Many of you are probably already familiar with this data, but just so we're all on the same page, Strava is a mobile app that folks can download and they can use to track their runs, their bike rides, all sorts of active modes of transportation. And like Andy had mentioned, Strava keeps all of this data, and they've recently made it available to municipalities and other planning organizations free of charge earlier on in the pandemic. Before that, Strava Metro had its data available for a price, and it's been collecting data since 2014. There's about 70 million users worldwide, so it's one of the most useful and complete sets of data that we have. There's other apps out there, but this is one of the more popular. So I'll go ahead and pass it over to Delaney to share a little bit more about what Strava tracks.
Thank you. So there are 3 different types of data that Strava is able to collect given kind of the design of the app and the way that users interface. The data that we worked with was the segment data. That has been used by lots of different researchers, especially to build heat maps and to predict bike traffic volumes and that sort of thing. Additionally, there's node and polygon data that can be used to make predictions about trip patterns. This map here is actually from the Strava Metro site and is an example in the Denver area that just shows that you can track popular routes versus the most used route, versus the most direct route, and that sort of thing. So very useful and very practical for that reason. The segment data that we used includes these tiny little line segments that correspond to certain segments of the trip. So it's not an entire trip that you can see, but rather just a little glimpse of it. And these are include lots of different variables. So it includes the male, female, total trip, total people, age information, time of day, and the trip type. So there's lots of information that Strava has collected. They also have a specific tool that helps them to track commuter trips versus leisure trips. And this is based on a lot of different assumptions about the different like destination or origin and destination kind of information and all of that good stuff. Without the node or polygon data, we can't determine the origin and the destination of trips. So this presents a challenge for certain comparisons, especially to census data, which uses the origin and destination information often. And it also presents some limitations in terms of how we track the trip pattern choices, because we can't actually necessarily tell which segments are connected within one actual real trip that a person is taking. And next slide, please. So this data, Strava data, is not location-based. It's not a location-based service, meaning that it doesn't track people's activity unless they opt into tracking their activity on the app. It also is important to note that the users are not necessarily a proportionate sample of the population. There are lots of different characteristics that could be skewed based on the sample. And something interesting about Salt Lake City and the Utah County that we collected, which we'll go into this a little bit later as well, but we collected some information about the count locate or from counter locations, so actual on the ground counters. And we found that Strava data represented about 10% of those trips between Utah County and Salt Lake City. And compared to many of the studies that we've looked at, people have found that it's about 3 to 5%. So we actually have a lot more people using Strava data in this area than perhaps the average. The chart on the left shows the number of Strava trips in like the gray color as compared to, or excuse me, the number of the Strava trips in the orange as compared to the count data in the darker gray. And this shows that there's a lot of variability across the different count locations. So at one count location, for example, Strava is capturing about 1% of the bike trips that are happening. And at a different location across town, they're capturing about 30% of the actual bikers or bike users. And so this just presents an issue as far as how do we actually tell how many people are biking and how many people are just using Strava, and kind of trying to create a relationship there. So something to note is that because of this like sampling bias that's going on, we advocate for using modeling to help actually create a better picture of on the ground bike trips. And this requires a certain set of skills that certain municipalities or planning organizations might not have access to. If you want to do your own analysis, you also will likely need to have data proficient staff and GIS software as well. And I will turn it over to Laura. Or sorry, Eric.
Jump in real quick. So now that we have a little bit of background about the data that we're using, these are the big research questions that we aim to answer this semester. We kind of divided up into 3 parts. The first one was a practitioner survey aiming to understand how other planning organizations across the country are using Strava Metro data, and Laura's going to speak a little bit to that later. The next part was a systematic literature review of anything that's been published in academia about Strava Metro data and how it's being used so that we could understand the best practices. And then finally, we performed our own validation and modeling. And from that, we wanted to know if Strava Metro data could actually predict bike counts along the Wasatch Front, and if these predictions can be improved by using other easily accessible public data sources. We specifically looked at American Community Survey information from the Census Bureau. And of course, we're always looking at the limitations of our model. And with that, I'll go ahead and pass the baton over to Laura.
We wanted to look at what cities, MPOs, and other state DOTs were doing with Strava data, if they were doing anything at all. We reached out to DOTs, MPOs, and cities in Texas, New York, Iowa, Oregon, California, Florida, and Utah to see if they used Strava data. The biggest thing that we looked for when reaching out is to see if we could find contact information online. Other than that, we wanted to look at areas of different sizes to see if budget, staffing, knowledge base, population, interest in biking, and other factors influenced the use of Strava data. We asked what the best practices or processes these areas had when using Strava. We asked what they primarily used Strava data for, what setbacks they encountered when using Strava, and if they did not use Strava, we asked why. The recommendations that we received from practitioners will be covered near the end of the presentation. While we waited for responses of recommendations from practitioners, we looked into existing literature about how Strava data has been used and ways that Strava data could be verified with data that we have available for us. Let's go to the next slide.
To conduct the systematic literature review, we followed the PRISMA protocol consisting of 4 basic steps, which are identification, screening, eligibility, and final inclusion. We started with searching the key term Strava and utilized 5 database platforms, which are Web of Science, Scopus, ProQuest, EBSCOhost, and TRID. Along with this database searching, we also conduct the manual searching, and we found 489 papers in total from the identification process. At the second step, which is screening, we removed 205 duplicate articles and headed with the remaining ones. And in this step, me and Jessica separately flagged all the articles as yes, no, or maybe. And Professor Andy resolved any conflict between my and Jessica's decision, and we excluded in 230 studies by reading title and abstract and duplicating issues, and ended with 54 articles. In the third step, we applied the inclusion and exclusion criteria to find more meaningful articles which meet our research questions, as we had some inclusion and exclusion criteria. So through this process, we started with 489 papers and filtered down to 27 papers. So for the full text analysis and detail synthesis, from the selected 27 articles, we extracted data for the data on the study area's density, contributing countries, active transportation rate, to find if there are any Strava uses pattern by the density or by the country. So next slide, please. So in case of data analysis and summary, we used the population density as our basis, and to do so, we arranged the study areas as the ascending order by the density and categorized them as first tertile as low density, second tertile as mid density, and third tertile as the high density areas. So let's have a brief on our findings and the correlation studies. Now, if we started with the Canada, then we see that in Canada, the correlation values between the Strava data and the conventional volume data is pretty high, and in case of low density area, the correlation value is high, and one of the possible reason may be the bicycling using rate in Canada's low density study area is quite high, that is 0.2 to 7%. And but in with the rises in the population density, the correlation value decreases in Canada, and this scenario is more or less common for the whole 3 countries we are comparing, that is Canada, US, and the UK. And if moving on, if we see the US cities, we found that the correlation values show a trend where the correlation value decreases when the population density increases. If you see that, the low density study areas have higher correlation values than the mid density and then the high density areas. So although the density for the R value is quite high, it has in case of UK, from this slide, you can see that the correlation values follows a trend that the higher density areas has the lower lower correlation value, but the exception is the some like UK. UK has the higher correlation value for the high density areas. This may be due to the fact that the UK's studies are conducted in only one study areas, or we have all found that are conducted on the city of Glasgow. That may be the possible reason. So that was the short brief from our analysis. So I like to invite Jessica to continue the presentation.
All right, for our example of a low density area, we chose a study done in Maricopa County with 185 people per kilometer squared. In this study, they compared Strava data to the bike count data provided by the Maricopa County Association of Governments. Using a simple linear regression, they found that the Strava data accounted for 76% of the variation between the two data sets. The goal of this study was to correct bias in the Strava data, and after adjusting for or using residential areas, distance to green spaces, speed limit, median household income, and the percent white population, the Poisson model came out or gave an R squared of 0.64. However, they did find that the bias corrected data accounted for 86% of the bike count data and 80% of the road segments. And then for our mid-density area, we chose a study done in Austin, Texas, where the population is 1,000, or the population density is 1,161 people per kilometer squared. In this study, they compared Strava data to the bike count data generated by automatic traffic recordings. Through performing an ordinary least squares regression, they found that the Strava data accounted for 81 to 91% of the bike count data. To further validate the Strava data, a spatial autocorrelation test was run using the Strava data, the bike count data, and then cycle tracks, which is a GPS tracking application, and that resulted in a correlation of 0.9. All right. For the high density, we go to the next slide. Sorry, there you go. For our high density example, we chose a study done in Glasgow, Scotland, where the population is 3,813 people per kilometer squared. In this study, they compared Strava data to the cordon count data. Through a Pearson correlation, they found that the Strava data accounted for 82% of the cordon count data when aggregated hourly, and then 91% of the data when aggregated at a daily level. Overall, these studies generally show that Strava data can be a good model to predict actual cycling counts. Next, we'll talk about data access and consolidation.
All right, so as you can kind of tell from some of the studies that have been included in our review, data proficiency is required to process the Strava data on your own. Although it is possible to use the data analysis tools that Strava Metro already has available, kind of like the figure I showed at the beginning of the presentation. basic understanding of SQL language to create a database for large data sets can then allow analysts to open data sets and extract specific variables from the large tables. So if this isn't something that people are necessarily familiar with, just suffice it to say that processing the Strava data on your own can be difficult in terms of resources that have to do with coding or data engineering, et cetera. So this is just a flowchart of kind of how we went about combining the spatial data with the different variables that Strava has available. And in order to give more meaning to the data that we kind of just combined here, we did have to go and use correlation and modeling. And Kendall and Hassan are going to go ahead and describe that now.
Okay, so for validation work, we collected bike counter data from locations in Salt Lake City and also from Utah County's MPO, Mountain Land Association of Governments. So this relationship between counter data and Strava is most used throughout the research, as we've seen, to verify the effectiveness of Strava. And so we used a Pearson's correlation to determine that relationship between counter and Strava data. And so in total, we had 17 locations, 5 were in Salt Lake City and 12 in Utah County. And these were during the months, of 2019. We broke it down monthly so that we could expand the data set and check for those inner variations from month to month. And so we did, see, here's the map of the different locations. So we looked at, so it went as far north on the Jordan River Trail, 1800 north to as far south over in Mapleton on the Canal Trail. And then, and a lot of the popular trails had counter data, including the 9 Line, Jordan River, the Murdoch Canal. And when we also had one that was directly on a bike lane in downtown on 300 South. So we did a that Pearson correlation for each location individually, for each agency, and then also system-wide. And so just a quick refresh on the Pearson correlation. It's ranges the coefficient from -1 to 1. If the number is negative, it's a negative relationship, positive relationship. And the closer to 1 in either direction is a stronger relationship. And so most counters correlated positive with Strava data, and they're very strong relationships. There are a couple exceptions to this, one of those being on the 9 Line in the west, 1250 west, and then also the Mapleton Canal Trail. And just kind of going maybe inferring a little bit. So Strava is an app used for activity tracking, and it's often used for recreational uses. And so some of these locations that maybe aren't doing as well could be one that they're not as popular recreationally, but also that people in those areas may not have as much access to the app for lack of smartphones. For example. But so total coefficients show that Strava data does correlate very well, both in Utah County and Salt Lake City, and system-wide at 0.79.
Okay, now based on our research questions, we're going to see if we can make Strava data useful for planning studies or not. As you have heard so far, we have 3 different types of data. One is Strava, which my friend described how this data is captured and what information is included. And another one is ACS, or census tract data, which is publicly available and is based on trip generation. And there are so many different variables within ACS data, and many studies have been using ACS data. And the third data source we have is bike count, which is the gold standard. And this is what we received for our study from Salt Lake City. As Kendall mentioned, we have this data for 12 different locations. And the limitation with this data is that it is not available for many other streets or trails. And as we know, decision makers and planners, they need high quality studies that use high quality data to make decision and plan for future. And that's why it is very important if we can come up with a good model by using Strava data. So based on that, we have explored two different routes with two different models. One to see if we can use Strava data to improve ACS bike estimate model and have more accurate prediction. And another one is to see if we can use Strava data to actually predict the bike traffic count. So on the first model, we used log-log, a linear regression, and our dependent variable was ACS bike estimate. While on the second study, we used bike count, which we have for 12 location and was collected in field, and used that as independent variable and try to see if we can predict the same number with Strava data. And so this is the result of our first model that we used ACS as our independent variable. You can see there are three different models, and the best model so far for our study is model number 3 that we have. You can see the adjusted R-square is 0.17, which is not great. And we might be able to improve the result by adding more built environment variable to the model and some socioeconomic variables. But something is important is that in all three models, Strava data shows statistically significant relationship with ACS count. And this means that Strava has the potential of improving ACS model, and depending on some additional variables, we might be able to use Strava with additional variables to improve the ACS models. Sorry if the text is kind of tiny. Again, the coefficient for Strava was very significant for our first model. And our second objective was to see if we can take advantage of Strava data to predict bike traffic in different streets. As I mentioned, we have bike count only for 12 locations in Salt Lake County and 5 locations in Salt Lake City, which is great. I mean, the data is very valuable. It covers the data for those specific locations for each month and for different hours. So it's very fine-grained and good data, but it is limited to those locations. So if we could use Strava data to have to predict bike traffic in every single street in the city or wherever the planner or decision makers want to plan for future, that would be very valuable because we know that field count is very resource intensive. So, and based on our model, because the number of locations was limited to 5 in Salt Lake City, that was a significant limitation for our model. We tried to include the bike count number for each month. So for each location we had 12 numbers, and that's why to overcome the limitation of the model, we had to use mixed effect generalized linear regression model, which is multi-level model, and every single month is nested within each location. And that's why we used multi-level model for this section of the study. And again, for all 4 models, Strava was pretty significant. And this is very good sign. And model number 4 was our best model with larger and bigger likelihood ratio. And again, comparing AIC and BIC for other models, this model was the best, which we combined Strava data, Strava bike data with percentage of white population, percentage of male, and household income. And the p-value for Strava was significant, 0.0. And especially for this model, we had pretty good results. And we believe that by improving this, we might be able to use Strava data for smaller cities that they don't have budgets to install counters for every locations, or even for larger cities that they can overcome the resource intensiveness of field data collection to come up with prediction for bike estimates for every single street. And I will pass it over to Lara.
So New York City is the only respondent from our practitioner survey that said that they don't use Strava data and they do not plan on doing so. Strava would duplicate a good portion of the data that they already have from permanent counters, travel surveys, American Community Survey data, and other data. So they don't think it's worth their time, effort, or at the time that they looked into it, the money to pay for the Strava data. Council Bluffs, Iowa is another respondent. They are a small city and they don't have the staff to dedicate to looking into Strava data, and the employees that they would use for that don't have enough knowledge to be comfortable looking into Strava data and how to use it. They would benefit from partnering with their NPO MAPA or their state DOT to be able to use Strava data effectively, and they would be very interested in using Strava to help plan for their active transportation network. The Texas DOT does use it, and they process and break down the Strava data into smaller sections. This means that it's easier for NPOs and cities to download the data, work with it, and understand it. So anyone can use the Strava data regardless of their knowledge of GIS, SQL, or any other technical information. Texas DOT also uses Strava data to guide where permanent counters can go in the state, where there are conflicts between people who bike and any other transportation mode, and where high traffic volumes of bikers don't have the infrastructure they need to be safe or go on long certain routes. Texas DOT also recognizes that most of the people that use the Strava app are biking recreationally instead of commuting or doing any sort of other sorts of trips, but they appear to not be doing anything to counteract that potential bias that they see in the Strava data. Other MPOs that responded are weighing the pros and cons of using Strava data in active transportation planning, even though some of them do have access to it. The benefits are appealing, but their analysis is inconclusive on whether or not they should be using Strava data. I will now be passing it over to Delaney to talk about the recommendations that we have.
So as we've noted kind of throughout this presentation, there are many applications for the Strava data and trying to model the bike counts across an entire area rather than just at certain counter locations. And because each city is different and has different data available and also has different infrastructure and bike culture or transportation culture in general, other municipalities should really dig in and try to figure out which variables to use for models of their own if they have an interest, which hopefully throughout this presentation, you understand the potential that exists using this type of crowdsourced data. But methods used in our analysis can potentially help guide those with limited modeling experience or certain municipalities that aren't sure where to start. Can also hopefully contribute to a library of resources that MPOs or transportation departments that are already doing different types of modeling can hopefully tap into and use as well. So we are excited about the potential here and have found a lot that hopefully will be useful in the future. Next slide, please.
Okay, so moving forward, we're planning on having 2 papers kind of sharing our results with the world published soon. One of them is going to cover that literature review that was done by Faria and Jessica, and the other one for that validation and modeling team. So everybody's going to be able to have the opportunity to look at our model and then maybe follow some of those recommendations that Delaney shared. And I think, Kendall, this is a good place for us to stop. And we can answer some questions if anybody has those. You're welcome to raise your hand if you have a question or just unmute yourself. And you can direct questions just at the group in general or at a specific presenter if you have a question about something they shared.
Before we go into the questions, I'd like to give a big applause, round of applause to all our students. Very, very interesting work you guys done. Questions, comments?
Hi, I'll jump in. This is Steph Tomlin with UDOT. Yeah, I would just echo what you said, Andy, kind of applause to the student. It was a really great presentation, well organized. So nice job to the students for putting that together. I did have a question about if or how you accounted for any issues that came up within the count data. So that's something that we know can happen sometimes, like a counter goes down or is miscounting for various reasons. Like they're very sensitive devices, and anything from like a insect infestation to, you know, it kind of the line being cut on the counter can affect the counts that it's producing. So I was curious if that played into any of the work that you did in the validation, or if you noticed that when you looked and compared the Strava data with the count data. Thank you.
Yeah, I can answer to that. So we did have more than 17 locations that we were working with, both from Salt Lake City and also from MAG, but there were some that had anomalies that, right, maybe it was a bug infestation. It was in the tens of thousands in the counter. But also just with some of them, with a couple, when we did the correlation, I think the 9 line was one of them. We didn't have every single month. And so we only did the correlation for the months that we did have full data with Strava segments that correlated with those months. So there was some fine tuning and just kind of looking at the numbers just generally to make sure, yeah, that for sure that those there wasn't anything too crazy going on with the actual counts. So I hope that that kind of answers that.
Yeah, it does. Thank you.
And just to add to that, I think that the counter data is very valuable. I know it's a resource intensive, but it's a repeat measurement, an automatic measurement. So even if the one counter goes down, you have other counters, and also you have year-long data to corroborate against the Strava data. So it's in a way it's a lot much better for this type of validation and also improvement work as against to using some of the census-based data, which is done every year or even 10 years. So I think it's the quality-wise, I think it's a lot better than traditional survey-based data. Other questions, comments?
I think you folks drew a good or suitable attention to the fact that the Strava sample is sort of inherently biased. And one of the things that we talk about, WFRC, this UDOT, others, is just the fact that our counters are also biased, right? We tend to have counters put mostly along pathways versus on-street infrastructure. So we've got a biased sampling in the Strava data. We've got counter locations which are biased. I'd be curious to hear a few students, especially those who were kind of involved in the statistical analysis, like step back a little bit and kind of maybe talk about how well the research that you did, the analysis that you did, matches your mental model of what's going on out in the real world, given that there's, that our samples are sort of limited at this point.
I can answer from the practitioner email surveys that we've done. They have been using Strava as a way to say, okay, it looks like these city streets or non-recreational areas have something going on that we didn't think was going on. Let's try putting counters in these locations to see if it's worthwhile, or doing in-person counts before moving to a more permanent counter. I think that might be a potentially good place to start for countering some of that bias, is looking at existing data to see where we could go from there, from Strava.
Thank you, Bert. And I wanted to add a point that so far we have tried a couple of different models, and going back to what you mentioned, there are some issues with modeling. I think we should try spatial autocorrelation to kind of overcome the limitation of adjacency, especially for our ACS model, which we have different census tract and ACS and Strava data adjacent to each other, and geographically these are correlated. So our next step, I think, would be, as you mentioned, to step back and look at our model again and probably see if we can come up with a better model. But yeah, this was the result that we have been achieved so far, but the work is going to be continuing to improve.
Yeah, and going to what two of our students said, so this is something that we discussed very much in the beginning of the class about the bias in the big data. And we talked about it, and we went through some of the examples as well. And I guess some of the key questions that a lot of people are dealing with in big data world is, a lot of people are excited about the data-driven research, which is, creates a lot of bias because of the data generation process and also data, how it's being analyzed and visualized. But what we are thinking and we are sort of moving towards is the research-driven big data collection. And that's what Laura was talking about. A lot of the municipalities were not actually using big data or Strava data to do an estimation, but rather using big data to sort of do more, the targeted data collection. So using big data as some sort of like a sensor rather than to doing a prediction. So I think some sort of, combination of both the prediction and also the being able to sort of guide that data collection process would become immensely useful as we move forward. And that's why we're thinking of not just doing the data modeling process, but also trying to come up with what practitioners are saying and what they're using in terms of the big data, both the analysis and collection. So yeah, I'd like to hear what you're thinking in terms of how you are actually using big data in your own practice for your research. And as we're wrapping up our research, a lot of the comments and information would become really useful for us to move forward. Any other questions, comments?
I'm Andy from WFC. I think it's great to see all this kind of data model practice. So how I may miss some of the slides, but I haven't seen the R-square, how good the model is, and how you choose like a linear, nonlinear, which kind of model to do the estimation. So can you kind of go back to that slide and do some articulation about that?
Yeah, for multi-level model, I wasn't able to calculate pseudo R-square, but I compared a couple of different measures like AIC, BIC, and likelihood ratio with each other. But I didn't put the result here. But based on those, we noticed that this model is the best in compared to other models. And for ACS data, we have adjusted R-square as 0.17. But again, I think if we include more built environment variables or demographic variables, we can improve the adjusted R-square for the model.
So you think the adjusted R-square is not good enough?
It's not ideal. Yes, I think we should work with other variables to see if we can improve the adjusted R-square.
So which kind of magnitude are you planning to achieve, like 0.9, 0.2, 0.5?
I don't know, it's a tough question. Andy, you can address this if you want.
Well, I think it's kind of coming from the different, I think that there are two things going on. One is the census data is the survey data. So it's not actually capturing what's going on the ground, but it's rather a trip generation potential in that location. So that's versus the counter data, the byte counter data is actual snapshot of what's happening. So it's very different data. And like what the Bert was saying, that it's the counter data, the counter locations are sort of not within the cities, but in other locations or more popular recreational places. So the ACS and census data is very different from the traffic counter data. And a lot of the reason behind why there's high correlation or the model fit with the counter data, with Strava data, is because of the fact that a lot of the users or Strava users are recreational users, and it's not everyday commuters. So that's basically what is going on in terms of the model fit and the correlation. And we just have to be mindful of what kind of data we're using, how it's being generated, how it's being analyzed, and what would be the best strategy to actually move forward when we're actually thinking about using big data. Or it's not just going to be Strava data, it could be any type of different types of big data, but we have to be mindful of the data generation process and how it's being analyzed and how others are using. So hopefully a lot of our efforts were useful and informative for not only just the the active transportation community, but also the transportation planning community in general.
So what's I don't want to talk about this again, I think, but what's the number, also the R-square or adjusted R-square in the literature?
The adjusted R-square, it's usually what they use is a counter data. So some of the innovations that we're taking is we use the census data. And we use the Strava data to predict census data. That's why our R-score is pretty low for other studies. Most of them use by counter data. So their R-score was pretty high, around 0.7, 0.8. So which makes sense because it's completely different data, different types of data, how it's being generated. But we try to see if the census data is, we can actually use census data and use a Strava data to predict census data. And we had an assumption that, the Strava data is not going to have a high predictability when it comes to ACS type of data, but we tried it anyway. And as the other results show, with the bike counter data, we obtained very high correlation as expected, because the data generation process and how it's being generated in the big data world is kind of similar. That's sort of the big difference. And I think that moving forward, we need to corroborate not only just the one type of data, for example, the counter data that everyone uses, but also different types of data and different types of, the travel behavior, not just the recreational travel behavior, but also everyday commuting behavior, and see if Strava data is useful to inform that sort of, the travel behavior, the patterns. And I guess Hassan can share some of the results with the bike counter data, and as we expected, the R-score was pretty high with the bike counter data.
Good.
Yeah,
I guess this kind of question could be asked by if the paper is going to be published, the reviewer will ask for this. So
yes,
the last
absolutely.
question is about the ACS data. So your data has the specific location, right? When you try to estimate model, you have like a specific location, maybe a specific month, and that's one record. But which kind of unit or geographic unit for the data from ACS? Is that like a certain block level or block group, or which kind of level? So
Yeah, we were mostly using block group, and then we were doing some of these results for the Utah, for the whole state, statewide by census tract.
good, thanks.
All right, so we're almost close to our time. If you have any last minute question, please do. All right, so thank you everyone for joining us today. As we're moving forward, we're wrapping up these projects, and hopefully we're trying to publish these results. So we'll keep you updated, and I'll put my email down here in case you're interested in getting more updates from us. But thank you everyone for joining us today. Hope you have a wonderful holiday and the end of the semester.
Thank you.
Thanks.
Thank you.